Imagine you are walking in a forest. Not a forest of today, with its marked trails and hiking signs. A thick, ancient forest. A forest that has never known the axe. It is cold. The air smells of resin and wet earth. Beneath your feet, the dead leaves of autumn form a spongy layer that cushions each of your steps. And you stop, because at the edge of the trees, maybe 100 feet away from you, there is someone, a standing being, bipedal, and two eyes looking at you. A face you almost recognize. A familiar structure, a forehead, a jaw, something human in the posture and in the gaze, but not quite you. A little broader in the shoulders, a forehead that slopes back slightly above the eyebrows, a silhouette holding its own spear the exact same way you would hold yours. You look at each other. Neither of you moves. This moment, this look between two beings who recognize one another without entirely understanding one another, happened thousands of times on this planet. For hundreds of thousands of years, in the forests of Europe, on the coasts of Asia, in the valleys of Africa, and on islands we didn't even know existed, beings of the genus Homo crossed paths. They looked at each other, sometimes avoided each other, sometimes approached, and sometimes had children together. And we have completely forgotten that it ever happened. Before we go any further, I need to know one thing. Where are you listening from tonight? From New York, from Texas, from London, from Sydney, from Toronto, or from a place I wouldn't have even thought to name? Tell me in the comments. I am genuinely curious to know where night is falling for you right now while you listen to this story. And a second thing, since you are here, if you think this kind of documentary deserves to exist, true history told slowly in the night, consider subscribing. It helps more than you might think. And now I have a question for you. One I want you to think about tonight, just before you fall asleep. If you had crossed paths with someone from another human species, someone who wasn't quite you, but almost, do you think you would have recognized them as a kindred spirit, or would you have been afraid of them? We learned a certain version of human history in school, in documentaries, in museums, a progression. Homo habilis, then Homo erectus, then Homo sapiens, a series of neat stages, ordered like a staircase leading right up to you, as if each species waited patiently to be replaced by the next before stepping aside in flawless order. That is not what happened. What paleontology and genetics tell us today is that human history looks far less like a staircase and much more like a dense, tangled bush, with branches growing in parallel for hundreds of thousands of years. Branches that cross, that touch, that sometimes melt into one another, before one of them finally takes over entirely. Homo sapiens, our species, is not the heir of a single solitary lineage. We are the survivor of a world populated by others. For the vast majority of our existence, we shared this planet with at least 4, 5, maybe 8 other species of the genus Homo, species that walked upright, that made tools, that lived in groups, took care of their children, perhaps tended to their dead. Human species, truly human, and they have all disappeared. Let me set the scene for you. We are roughly 45,000 years in the past. The Europe you imagine does not exist yet. No borders, no cities, no roads, but the land itself is there. The mixed forests of what will one day be France, the open steppes to the east, the rugged coastlines of the south. It is colder than it is today. In places, glaciers push down from the mountains we will later call the Alps. In that Europe, two human species are living at the exact same time. Homo sapiens, to keep it simple, has just arrived from the Near East, carrying spears with napped flint points, shell ornaments, and something in its way of communicating that we haven't entirely put a name to yet. And the Neanderthals have been there for more than 300,000 years. Think about that number for a moment. 300,000 years. If you compress the history of modern humanity, roughly 300,000 years for Homo sapiens, the Neanderthals occupied Europe for a span of time equivalent to our entire existence. From the first stone tool chipped by an anatomically modern human, all the way to the moment you are listening to these words tonight. They had already lived through something exactly that, long before our ancestors ever set foot in Europe. These are not primitive creatures. They are established, adapted, capable beings. Beings whose presence on this continent predates ours by a ratio that makes the mind spin. Now put yourself in the skin of a Neanderthal from that era. Not a cartoon character with a heavy jaw and a lumbering step. A real being, sitting that night at the entrance of a rock shelter in what will one day be the hills of southern France. The fire burns in front of you. Your hands are scarred. An old mark on your right palm from a hunt that went wrong 3 winters ago. You tended to that wound yourself, or someone tended to it for you. Both are entirely possible. Outside, a light snow is falling, and somewhere just a few days' walk away, groups of creatures you have never seen are moving toward you. They are slightly slimmer than you, slightly less robust. Their foreheads are different. Their throats emit sounds that are more varied, more complex. A rustle of communication you don't fully understand. You don't know they're coming yet. You don't yet know what their arrival will mean for you, for your children, for everyone who looks like you. For decades, scientists debated a fundamental question. Did Homo sapiens and the other human species actually meet? Or did they simply occupy the same regions, sequentially, one after the other, without ever really touching? The answer came from genetics, and it changed absolutely everything. In 2010, the Swedish geneticist Svante Pääbo and his team published the first complete genome of a Neanderthal, extracted from bones more than 40,000 years old. What they found stunned the scientific community. Between 1 and 4% of the DNA of every person of non-African descent is of Neanderthal origin. Not as a mere trace, not as an anecdotal quirk. These are active, functional sequences that influence real aspects of current human biology. In other words, our ancestors didn't just watch the Neanderthals from the edge of a forest. They had children with them. That very same year, the same team identified a second unknown human species from a single pinky finger bone, a species we would come to call the Denisovans. Once again, their genes are present in the bodies of millions of people living today. And that is not all. Later, a French-Philippine team described a third unknown species in a cave in the Philippines. In 2013, a team in South Africa discovered a species with a brain a third the size of ours, hidden away in an almost inaccessible subterranean chamber. Genetic ghosts in certain African genomes suggest there are species whose fossils we haven't even found yet. The world we thought we knew so well was populated by humans. Other humans. And they are all gone. There is something strange about this solitude we inhabit today. Something historically new and radically unprecedented, even if we don't feel it as such, because we have absolutely no memory of what it was like before. For the first time in at least 300,000 years, and perhaps much longer, only one species of the genus Homo wakes up each morning on this planet. Only one species builds cities, crosses oceans, observes the stars, listens to stories in the dark before drifting off to sleep. It is us. And this solitude is so ancient to us that it feels normal, natural, final, as if it had always been this way, and as if it always had to be. But it wasn't always like this. For hundreds of millennia, there were other eyes, other fires, other hands shaping stone, and other voices calling their children in the evening. On this continent you now call Europe. In those islands of Southeast Asia, you could fly across in a few hours. In South African caves, that light never reached. Other beings of the genus Homo lived their lives, and tonight it is their story we are going to tell. Close your eyes for a second. Not for long, just enough to imagine this. You are not the last human on Earth. You are one of the last of a long list of species that shrank slowly and then very quickly until only one was left. It is a strange feeling, this thought. A little heavy, a little dizzying. But it is the truth. And the truth sometimes is larger than what we thought we could hold. Begin to settle into it gently, into this vertigo of deep time. Because the night is long and we have many worlds to recover before dawn. We have to go far back to find them. But the first of the species we are looking for is not a stranger. It is the being that started it all. The one that left Africa before all the others and lasted longer than we ever understood. Chapter 2. The being who walked first and lasted the longest. That fire you imagined. That fire at the entrance of the Neanderthal shelter in the hills. Someone mastered it before them, long before them. And it is with that being that everything truly begins. Here is something most people don't know. We are not the most enduring human species in history. Not by a long shot. Homo sapiens has existed for roughly 300,000 years. That is the current scientific consensus ever since the redating of the Jebel Irhoud skulls in Morocco in 2017. 300,000 years. It is a massive amount of time. It is a duration the human mind struggles to grasp intuitively. But Homo erectus, the being we are focusing on tonight, lived for almost 2 million years. 2 million. A ratio of nearly 6 to 1 compared to our own species right now. If you wanted to represent those 2 million years on a yardstick, the entirety of Homo sapiens' existence wouldn't even fill the last inch. If duration of survival were the measure of evolutionary success, we are not the most accomplished species of the genus Homo. We are, for now, simply the last ones standing. Homo erectus appears in Africa about 1.9 million years ago. They are the first member of the genus Homo to leave that continent. Perhaps 1.8 million years ago, maybe earlier, according to some sites. They reach the Caucasus, China, Southeast Asia, and eventually make their way down to islands that only a being capable of navigating or crossing narrow straits of water could reach. They are tall, robust, walking entirely upright, with a gait that doesn't fundamentally differ from yours. Their face is flat, their brow ridges pronounced, their skull elongated toward the back. Their brain represents about 2/3 the volume of yours, somewhere between 850 and 1,100 cubic centimeters, depending on the specimens and the eras. And they master fire. The oldest evidence of the controlled use of fire by a hominin dates back about 1 million years in South Africa and Israel and is associated with Homo erectus. This isn't guesswork. Hearths calcined bones burned plant remains in contexts that cannot be accidental. Someone decided to sit near the heat and keep it alive. Think about what that represents. Fire isn't just a practical tool, even if it obviously is one. It protects from predators. It warms, it cooks food, and makes its digestion more efficient, freeing up energy for the brain. But fire is also a place, a center, a spot around which a group gathers after night falls. Homo erectus didn't just live with fire, they lived around fire. And that distinction, subtle as it may be, says something important about the kind of social being they were. Let's go back to that island, Java in modern-day Indonesia. The banks of the Solo River at a place that will be called Ngandong. The year is 1891. A Dutch military doctor named Eugène Dubois requested to be posted in the Dutch colonies of Southeast Asia with a very specific idea in mind: to find the missing link between man and ape. Everyone tells him he is wrong, that he will find nothing, that this quest is absurd. He digs anyway. On the banks of the Solo River, his Javanese workers first bring up a molar, then a skullcap, then about 50 yards away, a femur. Dubois holds something in his hands that he cannot yet name. It is not a human being as he knows it, but it is not an ape either. The skullcap is long, low, with imposing brow ridges. The femur is straight along that of a biped, this being walked like you, upright on 2 legs. Dubois calls it Pithecanthropus erectus, the upright ape man. It will later be renamed Homo erectus. But Dubois' discovery is the first of its kind, the first human fossil discovered outside of Europe. The first proof that human history stretched beyond what anyone had imagined into lands and times that no one had yet mapped. Upon his return to Europe, the reactions are hostile. Colleagues accuse him of piecing together bones from different species. Others refuse to see anything remarkable in his find. Dubois, frustrated, ends up hiding the fossils under the floorboards of his dining room in Haarlem for more than 20 years. Refusing access, jealously guarding what he had found, waiting for it to be recognized for its true worth. He will die in 1940, partially vindicated, but never entirely at peace. Those fossils rested just a few miles from the place where Homo erectus made its last known appearance on Earth. This is where the story of Homo erectus suddenly becomes very strange. For a long time it was thought that Homo erectus disappeared about 400,000 years ago, when other, more recent human species gradually supplanted them across the different continents. That disappearance seemed clean, orderly, logical in the grand narrative of evolution. But a study published in the journal Nature changed the timeline entirely. The team, led by Russell Chocken of the University of Iowa, dated the geological layers of the Ngandong site with a precision that previous techniques simply didn't allow. The result: the last known Homo erectus lived at Ngandong between 108,000 and 117,000 years ago. 110,000 years. Let that number settle into its proper place. By that time, Homo sapiens already existed. Our anatomically modern ancestors had already begun to spread out of Africa. Human populations had already reached the Near East, perhaps the coasts of Arabia, maybe even the coasts of South Asia. And at Ngandong, on an island in modern-day Indonesia, a small community of Homo erectus continued to live, to hunt, to tend fires, with absolutely no idea of what was approaching on the neighbouring seas and continents. A final group, a last presence, a local extinction, and then silence. What happened at Nandong we may never know with absolute certainty, and it is one of the most fiery debates in modern paleoanthropology. One position, defended by researchers like Chris Stringer of the Natural History Museum in London, insists that the temporal coincidence between the expansion of Homo sapiens and the successive extinctions of other human species is no accident. Everywhere our ancestors arrive, the others disappear within a relatively short time frame. Competition for the same resources, the same prey, the same shelters, and perhaps the transfer of pathogens to which Homo sapiens was immune, but the others were not. These would be the primary causes. The other position, also supported by numerous researchers, insists that the climate changes of that period, brutal oscillations between hot and cold phases, regularly created conditions to which small, isolated populations of Homo erectus were simply no longer able to adapt. The resources collapse, the population shrinks. The minimum threshold for viability is no longer met. The two explanations are not mutually exclusive. And this inability to choose this honest uncertainty is in itself a kind of answer. Extinctions of the deep past are not simple equations. They are the result of an accumulation of pressures, some of which remain invisible to us. There is something deeply poignant in the image of that last community at Ngandong. Imagine them. A few dozen individuals, maybe a few hundred at the group's largest, living on the banks of the Solo, fishing, hunting deer and wild boar, sleeping under the cover of the dense island trees. Passing down their hunting techniques from father to son and from mother to daughter, just as their ancestors had done for almost 2 million years. They don't know they are the last. No one ever knows in those moments. One generation passes, then another still. And at some point, without any proclamation, without witnesses, without an identifiable event, there is no one left. 2 million years end without a sound. You might be walking tonight on soil that once bore their footsteps. Not in Java, perhaps, but anywhere on this planet that our two species shared, without ever, it seems, meeting face to face. The DNA of current Southeast Asian populations contains traces of ancient interbreeding with unknown human species, but nothing formally indicates that Homo sapiens and Homo erectus ever had children together. They coexisted on the same planet, in the same region of the world, at distances that couldn't have been immense. And yet, there may have been no exchanged glances, no encounter. Two species of the same genus, on the same island, in the same archipelago, just a few generations apart, and nothing. Or maybe there was. We just don't know yet. And that uncertainty, modest and immense all at once, says everything about what we still don't know of the world we grew up in. Let that image fade slowly. The edge of the Solo River, the dense forest. Someone watching the current flow by a hand resting on a knee, unaware that they are part of the last 1,000,000 years. And then nothing. Before the Neanderthals, before the Denisovans, before everything we will rediscover tonight, there was another species, the one we shared with them, the one we all descend from, and whose story illuminates exactly why the human family tree split the way it did. Chapter 3. The ancestor at the crossroads, before the paths diverged. The Solo River fades away. The island of Java recedes into the dark, into time. And now something even older rises to the surface. The question of what connected all these species before they became distinct. There is a truth in human evolutionary history that few people know, and that I personally find fascinating. At a certain point in time, there existed a being from whom you partly descend, and from whom the Neanderthals also descend. A common ancestor, a crossroads in the human tree. And this common ancestor didn't disappear in the ordinary sense of the word, it branched off. A part of its descendants remaining in Africa slowly evolved into Homo sapiens. Another part, heading north and east, evolved in Europe into the Neanderthals. For a time, a very long time measured in hundreds of thousands of years, the two halves of that same lineage lived on different continents, without contact, evolving separately into distinct forms. And then one day, they found each other again. Paleontologists give this common ancestor the name Homo heidelbergensis. It takes this name from a fossilized jawbone discovered in 1907 in a sand pit near Heidelberg, Germany, by a quarry worker named Daniel Hartmann. He handed it over that very evening to the director of the university's Natural History Museum. Daniel Hartmann didn't know what he was holding, but he sensed that there was something extraordinary about this heavy, massive bone that had slipped out of the sand. He was right. Homo heidelbergensis appears in the fossil record about 700,000 years ago, perhaps a little more. Tall. Some individuals must have approached 6 feet. Robust. With a brain volume between 1,100 and 1,400 cubic centimeters, sitting right in the low to mid-range of our own modern brains. They crafted flint tools with a sophistication noticeably superior to those of Homo erectus. They hunted large prey, rhinoceroses, horses, deer, and lived in structures that suggest a social organization far more complex than anything observed before them. They were also the first known human beings to regularly adapt to the cold environments of Northern Europe. Broader bodies, shorter limbs. A morphology that conserves heat better. This isn't a biological accident, it is an active adaptation to climatic conditions that their African ancestors had never encountered. And that is where one of the most dramatic yet least publicized discoveries in the history of paleoanthropology comes in. In 2023, an international team of researchers published the results of an unprecedented genetic analysis in the journal Science. Their tool was a new method called FitCole, which allows scientists to deduce the size of ancestral populations based on the genetic diversity of humans living today, tracing the thread of DNA back over vast scales of time. What they found stopped them in their tracks. Between 930,000 and 800,000 years ago, the common ancestral lineage, the one that would give birth to Homo heidelbergensis, then to the Neanderthals, then the Denisovans, and finally Homo sapiens, suffered a catastrophic demographic collapse. The breeding population dropped to roughly 1,280 individuals. To put that number into perspective, that is the current population of an average middle school in a typical American town. Everything that would become humanity, all its branches, all its species, all its future children, right down to you, tonight, fit into the equivalent of a single schoolyard. For 117,000 years that thread held. How? Why? We don't know. This chronological abyss coincides with a major climatic transition, the shift to longer, more intense glacial cycles, and perhaps a dramatic reduction in African forest cover. But the exact causes of this collapse remain unsolved. It is one of the deepest mysteries of human history and one of the least known to the general public. What we do know is that the thread did not break. And from that single thread, the human tree slowly rebuilt itself. There is something you need to understand about Homo heidelbergensis, something that changes the way you look at the rest of this story. This species, or this group of species, the debate is real over the taxonomic unity we group under this name, didn't just precede the Neanderthals and Homo sapiens in time. It is their common starting point. The bifurcation between our two lineages happened somewhere between 600,000 and 800,000 years ago, according to the most recent genetic and fossil analyses. Which means this: when the Neanderthals were evolving in Europe toward stockier bodies, larger brains, and perhaps more elaborate rituals, they were becoming what they were going to be from the exact same starting point as us. Our two species are like two children from the same family, raised in different houses for hundreds of millennia. They share the same parents, the same origin, but distance and time made them different. Different, but not strangers. This is not a minor detail. It is perhaps the key to everything that comes next. And there is an archaeological site in Spain that illustrates all of this in a striking way. The Cima de los Huesos, the Pit of Bones, in the Sierra de Atapuerca in Castile, a deep cavern connected to the surface by a natural shaft with a 40-foot vertical drop, where human bones began to accumulate some 430,000 years ago. The researchers who explored this site in the 1970s, and who are still working there today, have extracted more than 6,500 human fossils belonging to at least 28 different individuals. Men, women, children, teenagers, adults, the elderly. An accumulation of such density that it cannot be accidental. These beings were brought there, deposited in this pit with intention. These beings are representatives of Homo heidelbergensis. Among the bones, a biface hand axe made of red quartzite, a tool with no traces of use too large for an ordinary grip, a symbolic object perhaps, an object that wasn't there by chance. A being with a brain that reflects on death, that does something with its dead, that carries a red object right into the dark of a cavern and leaves it there with those who will never walk again. We do not call that a civilization, but we recognize something in it. The central debate around Homo heidelbergensis is precisely about its unity. Some researchers, including the teams working at Atapuerca, believe that the European fossils attributed to this species actually constitute a distinct lineage close enough to the Neanderthals to already be considered pre-Neanderthal. Others maintain that a unified Pan-African and Pan-Eurasian species preceded the split. Still others question the existence of Homo heidelbergensis as a valid category altogether, arguing that the diversity of the fossils grouped under this name is too great for a single species. This disagreement is not confusion. It is an honest reflection of reality. Evolving species are not neat categories. They are gradients processes, rivers that gradually divide, rather than roads that branch off cleanly at an intersection. What we call Homo heidelbergensis is perhaps less a proper name than a provisional description of that moment when a single being is still figuring itself out before becoming many. Night fell a long time ago at Atapuerca. The pit has been silent for 430,000 years. But those 28 beings resting in that stone shaft have something that all human beings after them will also have. Someone did something for them after their death. Someone thought of them beyond their physical presence. It is a form of memory, and memory in all its forms, fossil, genetic, oral, written, is the only thing that allows them to still exist tonight. In this story you are listening to in the dark, there is something calming in that thought. Those 28 individuals in their pit, the red axe between them, the silence of 430 millennia. They don't know what they started, nor what would come from their branching path, nor that two descending lineages would one day find each other in a European forest and look into each other's eyes without entirely understanding what they were seeing. They know none of this. They were just there together in the dark. From this crossroads, one of the routes led toward the north and the cold, towards stockier bodies, larger brains, and a species that would survive for 300,000 years before crossing paths with ours. It is toward them that we go now. Chapter 4. The Neanderthals. What 3 centuries of mistakes have cost us. In the pit at Atapuerca, someone laid down a red axe, a gesture toward the dead. And from that same impulse, doing something for those who are no longer here, the Neanderthals would. Hundreds of millennia later, build one of the most misunderstood cultures in all of human history. Here is the problem with the Neanderthals. We spent almost 2 centuries being wrong about them. And correcting a 2-century-old mistake, even with the best evidence in the world, takes time. It all begins in 1856 in the Neander Valley, Neanderthal in Old German, near Düsseldorf. Workers are extracting limestone in a quarry when they stumble upon human bones in a cave. They hand them over to the quarry owner, Johann Karl Fuhlrott, who passes them on to the anatomy professor Hermann Schaffhausen. What Schaffhausen examines is a long, low skull cap with thick brow ridges and limb bones of unusual robustness. The Irish paleontologist William King, in 1864, proposes that these bones belong to a distinct species and gives it its name, Homo neanderthalensis. So far, so good. The problem is what comes next. In 1908, at La Chapelle-aux-Saints in central France, an almost complete Neanderthal skeleton is unearthed. It is entrusted to the paleontologist Marcellin Boule. Boule publishes between 1911 and 1913 a description that will define the popular image of Neanderthals for the next 100 years. A hunched, stooped being with bent knees, a thick neck, prehensile feet, incapable of standing truly upright. A brute. A primate barely out of the trees. What Boule hadn't realized, and what the researchers who re-examined the skeleton in the 1950s finally discovered, was that the Neanderthal of La Chapelle-aux-Saints suffered from severe arthritis. He was old and sick. His spine was deformed by disease, not by the nature of his species. Boule had described a chronically ill man and concluded that this was the normal posture of an entire species. The image stuck. For a long time, the data didn't erase it fast enough. Here is what we know today. Neanderthals walked completely upright. The anatomy of their pelvis and lower limbs establishes this clearly. Their brain had an average volume slightly larger than ours, about 1,600 cubic centimeters compared to 1,350 cubic centimeters for modern Homo sapiens. It was a differently shaped volume. More elongated laterally, less rounded, but not inferior in absolute size. They made Mousterian tools, flint blades, scrapers, spear points. Tools that required planning, the transmission of knowledge, a mastery of materials that only a being with an organized mental life could produce. They wore ornaments. In several European sites in Spain, Italy, Croatia, we have found pierced shells coloured with ochre, bird feathers, mineral pigments mixed with animal fats. These objects serve no practical purpose. They serve something else. To be seen, to signify something, to represent oneself in a certain way in the eyes of others. And they buried their dead. Shanidar Cave in modern-day Iraqi Kurdistan was excavated by the archaeologist Ralph Selecki starting in 1953. He unearthed 10 Neanderthal individuals. One of them, Shanidar 1, is an adult male who survived multiple severe injuries. An arm that withered or was amputated in childhood, healed fractures to his ribs and leg, probable signs of partial blindness in one eye. To survive with these handicaps in Paleolithic Europe, to hunt, to follow the movements of a group, to face winters that sometimes plunged below -10 degrees Fahrenheit, required help. Food brought to him, care provided. Someone had been looking after Shanidar 1 consciously for a long time. This isn't anthropomorphism, it is what the bones tell us. It was Shanidar 4 that would spark one of the most enduring controversies in paleoanthropology. This Neanderthal, discovered in the 1950s in a layer dating back some 60,000 years, was surrounded by an unusual concentration of pollen. Selecki and his team, analysing this data with the palynologist Arlette Leroy-Gourhan, concluded that flowers had been intentionally placed on the body. A floral burial. The image is powerful, almost literary, a Neanderthal resting on a bed of wildflowers. For decades, this interpretation fascinated the public and fueled the idea that Neanderthals had an inner life, a sense of the sacred, something that resembled a funerary ritual. Then in 2023, a reassessment published in the Journal of Archaeological Science sowed doubt. Gerbils and other burrowing rodents, very common in this region, regularly transport seeds and pollen in large quantities into their burrows. The pollen concentrations around Shanidar 4 might just be the result of animal activity. Might be. Other researchers maintain that the spatial data doesn't fit the rodent model well, and that intentional burial remains plausible. In 2015, a new team from Cambridge resumed excavations at Shanidar and discovered new Neanderthal remains, Shanidar Z, in the same stratigraphic layer. The analyses are ongoing. The debate is not closed. What is certain is this: the desire to settle this question, to know whether beings with a brain slightly different from ours laid flowers on their dead, says something important about us. Not just about them. We have a deep need to know if we were alone in living this way. If rituals facing death were something unique to Homo sapiens, or if other beings also looked at their dead with something we might call grief. Now put yourself in that moment. Shanidar, 60,000 years ago, you are a Neanderthal. Someone you knew has just died. Maybe an adult in your group, maybe a child. Neanderthals buried their children too. The excavations show this clearly. You are in the cave with the others. It is cold. The light of a torch flickers against the limestone wall. What do you do with the body of this being you already miss? You cannot do nothing. Something in your cognition, in your ability to represent the mental states of others, in your memory of who this person was, demands a gesture, an action that says, he was here, she was here, and now that they are no longer here, it still matters. That is perhaps the true core of the Shanidar story. Not the flowers, which may forever remain uncertain, but the fact that the question even arises, that the bones are arranged in a position that suggests care, that Shanidar 1 lived for years with his injuries fed and tended to by his own. Something resembling tenderness existed in those caves. The Neanderthals disappeared about 40,000 years ago. After 300,000 years in Europe, after surviving glaciations that would have killed off most other animal species, after developing tools, ornaments, rituals, and after caring for their elderly and disabled. And then, 5 to 10,000 years after the arrival of Homo sapiens in Europe in significant numbers, they are gone. That delay, those 5 to 10,000 years of coexistence, is one of the most debated data points in paleoanthropology. Was it a gradual competition for the same resources, an exchange of diseases to which the Neanderthals were not immune? A climatic shift that shrank hunting territories. A slow genetic absorption through interbreeding with Homo sapiens. A dissolution rather than an extinction. We do not know. We know they were there and that they no longer are, and we know we were there too. Tonight, in your bed, you carry a little piece of them. Between 1 and 4% of your genome, if you are of non-African descent, is of Neanderthal origin. Sequences that influence your immune response, your susceptibility to certain viruses, maybe your tendency to wake up earlier or later in the morning. The Neanderthals are not truly extinct. They are dissolved in us. Diluted, fragmented, scattered across billions of living human bodies. Not present enough to define who we are, but present enough not to have entirely vanished. There was light in their caves. Fires they tended, bodies they cared for, dead they did something with, even if we are no longer sure exactly what. And then the light went out, slowly, silently. Not all at once, the way most important things end. But at the exact same moment, in the same caves, in some cases just a few miles away, there was another presence, a species we would never have suspected if a fragment of bone no larger than a coat button hadn't survived for 80,000 years in the cold rock of a Siberian cave. Chapter 5. The Denisovans. The species we only know by its ghost, the light of Shanidar fades, and in that same darkness of prehistoric Eurasia, something else is moving. Something no one would ever see directly. Something no one would ever hear named, and that science would only discover through the invisible footprint it left in millions of living bodies. In March 2010, Svante Pääbo receives a sequencing result in his Leipzig laboratory that forces him to sit down. His team has been working for years on DNA extracted from a distal phalanx, the tip of a pinky finger bone discovered in Denisova cave in the Altai mountains of Siberia. A bone fragment from a little girl, 5 to 7 years old, who died roughly 80,000 years ago. The Russian archaeologists who had sent it to Leipzig assumed it was probably a Neanderthal, the human species expected in that place at that time. What the sequencing reveals is something else entirely. The mitochondrial DNA from this bone differs from that of Neanderthals and from ours by a number of mutations, twice as high as what already separated Neanderthals from Homo sapiens. This is not a Neanderthal, this is not a modern human, it is something else. A third human species, unknown until this exact moment, identified not by a recognizable fossil, but by the molecular sequence of a bone fragment barely larger than a coat button. Pääbo would later say it was one of the most extraordinary moments of his career. He didn't see it coming at all. They call this species the Denisovans after the cave where the phalanx was found. And this is what makes the Denisovans absolutely unique in the history of science. We know them almost entirely through their DNA. For most extinct human species, we have fossils, skulls, jaws, partial skeletons, shapes we can measure, draw, photograph. For the Denisovans, after years of excavation, we have the phalanx of a little girl, a few large teeth, a fragment of skull, and a piece of a jawbone, found on the Tibetan plateau in the Baishia Karst cave at an altitude of 10,000 feet. That is just about it. What we know of their physical appearance comes from a technique developed in 2019 by a team at the Hebrew University of Jerusalem, epigenetic reconstruction. By analyzing the chemical modifications, the methylation of Denisovan DNA, they were able to infer which regions of the genome controlled anatomical development and make predictions about the physical traits of these beings. The result: Denisovans were quite robust, with a wide skull, a slightly sloping forehead, and above all, very large teeth, much larger than those of Neanderthals and modern humans. Characteristics more archaic than those of the Neanderthals. But this is an indirect reconstruction. No one has ever seen a complete Denisovan skull, which makes them a species we know as a ghost, present everywhere in the genetic data, almost completely absent in the fossil record, and yet this ghost has left traces in the bodies of millions of people living today. Melanesians, the peoples of the Pacific Islands like Papua New Guinea, Fiji, and the Solomons, carry up to 5% Denisovan DNA in their genomes. Aboriginal Australians do as well. Certain populations in the Philippines carry an even higher percentage, up to 6% of a genetic variant distinct from the Siberian Denisovans, which suggests perhaps two geographically separated Denisovan populations with which our ancestors had contact at distinct moments. 5% of a genome is considerable. For comparison, Europeans and Asians carry between 1 and 2% Neanderthal DNA. The Denisovan traces are at least as significant, and in some populations even more so. These beings we have never seen directly have left something very real inside us. But the most concrete gift the Denisovans gave to living humanity, the most measurable, the most visible today in real lives, is a gene. The EPAS1 gene. EPAS1 regulates the body's response to hypoxia, the lack of oxygen. At high altitudes, the air is thin and oxygen pressure drops. Most human beings respond to this deprivation by producing more red blood cells. It's a useful short-term response, but over the long term, it thickens the blood and increases the risk of blood clots, heart failure, and complications during pregnancy. Women from the high plateaus of Central Asia regularly suffer fetal loss because of this poorly regulated response. Tibetans and Sherpas do not have this problem. Their version of the EPAS1 gene, a version that differs radically from that of all other human populations, and which allows them to produce fewer red blood cells at high altitude while maintaining excellent oxygenation, comes to them from the Denisovans. This version of the gene was transmitted during a sexual encounter between an ancestor of the Tibetans and a Denisovan being somewhere in Asia, perhaps 40 to 30,000 years ago. Today, a Buddhist monk meditating at 15,000 feet in a Himalayan monastery. A Sherpa guiding an expedition to Mount Everest without supplemental oxygen up to 23,000 feet. An ultra-trail runner finishing a race at Mount Kailash when everyone else has given up, lungs burning. In their bodies, in this specific gene, at this exact spot on their chromosome 2, lives something that comes from a species extinct for perhaps 50,000 years. The species is gone. The gene lives and breathes. There is a moment in this story that surpasses everything else. In 2018, Viviane Slon and her team in Leipzig analyzed a long bone found in Denisova Cave. They expected to find a Denisovan, or perhaps a Neanderthal. What they found staggered them. The bone belonged to a teenage girl, about 13 years old at the time of her death, roughly 90,000 years ago. They named her Deni. Her mother was Neanderthal, her father was Denisovan. Not a distant descendant of these two species, a direct first-generation hybrid. Her mother was Neanderthal, and analyses show that this mother already carried a little Denisovan DNA herself, indicating that interbreeding between the two species had already occurred in previous generations. Her father was Denisovan and carried traces of DNA from an even older Neanderthal lineage. Deni was direct proof that these species did not live in airtight parallel worlds. They met, they recognized each other as kin, they had children. It wasn't rare, and it wasn't an accident. You might find this strange, even uncomfortable, this idea of hybridization between species. It is a common human reaction. A species is something watertight in our way of thinking about the living world. Two different species do not mix. That is the very definition of a species, isn't it? No, not really. The biological definition of a species relies on reproductive isolation. Two populations form distinct species when they can no longer reproduce together. But this threshold is not a sharp line. It is a gradient. Closely related species can reproduce together while remaining distinct in most of their characteristics, especially if their populations are geographically separated most of the time. Wolves and coyotes do it. Brown bears and polar bears too. Certain dolphins. And closely related human species in rare encounters spaced out over time did it as well. Biology is messier than our categories, and that is perhaps a good thing. Somewhere in Asia, tonight a human being climbs the steps of a temple at 14,000 feet. His lungs function normally. His heart rate is calm. His blood does not thicken. He doesn't know why his body does this so well. He probably doesn't know what the EPAS1 gene is. He certainly doesn't know that this ability comes to him from a species that hasn't existed for tens of millennia. He climbs the stairs, he enters the temple, he places his hands on the cold stone, and he breathes. And in that breath, there is something incredibly ancient. The pinky finger of the little girl from Denisova, no bigger than your fingernail, 80,000 years in the cold rock, holding enough life inside to reveal an entire people. In the islands of Southeast Asia around that same time, another species was living its own life. A species that evolution had shaped in a radically different way in the isolation of an island, until it produced something no one had ever seen and no one ever expected to find. Chapter 6. The Hobbit of Flores. What isolation does to a brain. The breath of a monk on the heights of the Himalayas, breathing through a 50,000-year-old gene. And now come down from those peaks, down toward the sea, toward the islands, toward a cave on an Indonesian island where something even more unexpected awaits you. Evolution does not always progress toward bigger, more complex, more imposing. Sometimes it shrinks what it took millions of years to enlarge. That is the central fact of this chapter, and it is worth pausing to consider. Homo floresiensis, the species scientists unofficially nicknamed the Hobbit, was an adult of about 3 feet 6 inches tall, with a brain of about 380 to 420 cubic centimeters. For comparison, yours measures about 1,350 cubic centimeters. The brain of a chimpanzee is about 400 cubic centimeters. An adult human being with a brain the size of a chimp's. And yet, and this is where it gets frankly baffling, this species made stone tools of real sophistication. They hunted the stegodon, a dwarf elephant, also victim of the same island shrinking phenomenon, and they hunted it in groups, which requires coordination. They may have used fire. They survived on their island for at least 100,000 years, probably much longer. The idea that brain size directly determines behavioral complexity is one of the oldest assumptions in paleoanthropology. Homo floresiensis seriously complicates that. Flores, Indonesia, September 2003. The team of Australian archaeologist Mike Morwood has been excavating the Liang Bua cave for several years. It is a massive cave, a natural cathedral with a 60-foot ceiling and a flat floor that invites you to dream of what might have happened there. The team works in narrow trenches, layer by layer, with the patience that any serious archaeological work demands. On this September day, a local excavation technician named Benjamin Taras gently scrapes the wall of a trench and feels something emerge under his fingers. He calls Morwood. Together, with brushes and tweezers, they slowly uncover what turns out to be a skull. Small, strangely small, with a slightly protruding face and subtle brow ridges. Morwood knows immediately that he is not holding the skull of a child. The wisdom teeth are present. It is an adult woman, according to later analysis. An adult woman as small as an 8-year-old child. He would later say, with the restraint typical of scientists who know they are holding something exceptional, that it was one of the most remarkable moments of his life. He would die in 2013, 10 years after his discovery, leaving behind an entire species he had pulled from the darkness. The biological phenomenon at work on Flores is insular dwarfism. It is a well-documented rule of evolution. Large species isolated on islands tend to shrink in size over generations. Food resources are limited, predators are often absent, a smaller body needs fewer calories. Over thousands of generations, natural selection systematically favors smaller individuals. This phenomenon can be observed on islands all over the world. Dwarf elephants in the Mediterranean 10,000 years ago, dwarf mammoths on Wrangel Island in the Arctic that still survived just 4,000 years ago, dwarf hippos in Cyprus, and on Flores, likely a dwarf hominin. Because the probable ancestor of Homo floresiensis on the island of Flores was likely Homo erectus, who arrived there perhaps 700,000 years ago, and on this island, isolated from the large continental populations with no way back, Homo erectus shrank. Not suddenly, but over hundreds of thousands of generations, imperceptibly at each step, until the result was this 3.5-foot woman whose bones spent 50,000 years in the sediments of Liang Bua before Benjamin Taras found her. There were, of course, voices that challenged this interpretation. Some researchers propose that Homo floresiensis was not a distinct species, but simply a Homo sapiens suffering from microcephaly, a pathological condition that reduces skull size. The hypothesis was taken seriously and examined rigorously. It did not hold up, for several reasons. First, the cave yielded the remains of multiple individuals presenting the exact same anatomical characteristics. If it were a pathology, it would have had to be of extraordinarily high frequency in this small population. Next, the shape of the skull, the structure of the wrist, the morphology of the feet and ankles of Homo floresiensis do not resemble the pathologies of Homo sapiens. They resemble a mix of archaic traits and local adaptations unique to a distinct evolutionary lineage. Finally, revised dating in 2016 established that the species survived until about 50,000 years ago, which coincides once again with the probable arrival of Homo sapiens in the region. Once again, the same coincidence. A modern human arrives, another species disappears. The inhabitants of Flores have a very old oral tradition. They speak of beings they call the Ebugogo, small, hairy creatures who lived in the hills, who grunted rather than spoke, who sometimes stole crops from the villagers. In some versions of the legend, the ancestors of the current villagers finally drove the Ebugogo away by offering them fire, which they didn't know how to use. Are these legends the echo of a real coexistence? Did the ancestors of Homo sapiens on Flores actually cross paths with the last representatives of Homo floresiensis and keep the memory of it in this form? No one can say for sure, but the idea is not absurd. Oral memory can cross millennia, transformed and metaphorized, but recognizable in its broad strokes. There is another way to look at the legends of goblins, elves, dwarves, and strange humanoid creatures that populate the mythologies of nearly all human cultures. Perhaps some of these stories are far older than we believe. Perhaps they remember, in their own way, something true. Homo floresiensis is extinct. Its cave is open to tourists. The skull of the woman discovered by Morwood and Taras is a replica in a Jakarta museum. But on the island of Flores, from time to time, they still tell stories of small creatures in the hills. Memory takes whatever forms it can. Far away, thousands of miles to the north and west, another species that no one expected was waiting to be found in a cave that light barely reached. And what researchers would find there would force a question that no one really wanted to ask. Chapter 7. Homo naledi. A one-third brain, and perhaps funerals anyway. The legends of Flores speak of beings in the hills who didn't know fire. And now, in the bowels of South Africa, comes something even more unsettling. Beings who plunged into the dark of their own free will, without light, into passages that almost no adult today can traverse, and who perhaps laid their dead there. Here is the question that has troubled researchers since 2013. Can a being with a brain one-third the size of yours decide to do something with its dead? And if the answer is yes, what does that mean for everything we thought we knew about the link between intelligence and symbolic behavior? Most of us assume that burying the dead, funerary rituals, or the awareness of death as a concept, all of that requires a brain of a certain complexity, a brain like ours. Or at least like that of the Neanderthals, who had a comparable volume. Homo naledi had a brain of about 450 to 600 cubic centimeters, roughly the size of a gorilla's brain. And the bones of Homo naledi were found in deep underground chambers, separated from the outside world by tunnels just 7 inches wide, and in geological conditions that cannot be easily explained by chance. South Africa. October 2013. 2 amateur cavers, Rick Hunter and Stephen Tucker, are exploring the Rising Star cave system about 30 miles northwest of Johannesburg. They have known this network for years, but on this day they enter a passage they had never attempted. A limestone conduit so narrow that you have to exhale all the air from your lungs just to squeeze your shoulders through. 60 feet down this passage, then a 40-foot vertical drop in the pitch black. Then another passage, 7 inches wide at its narrowest point, the one they will later call the Superman crawl, because you can only get through it by extending one arm in front of you like Superman in mid-flight, and on the other side, a chamber. And on the floor of this chamber, bones, many bones, scattered across a clay surface. Bones that look human, but in the shape of the skull and the teeth, do not seem to belong to Homo sapiens. Hunter and Tucker take photos. Then they send the images to Lee Berger, a paleoanthropologist at the University of the Witwatersrand. Berger looks at the images. He looks for a long time. Then he launches one of the most unusual recruitment processes in the history of science. He posts a call on social media, looking for qualified paleoanthropologists and archaeologists who are simultaneously slender, capable of navigating extreme confined spaces, and available immediately. He gets dozens of applications in a matter of days. He chooses 6 women, all qualified scientists, all slender enough to make it through the Superman crawl. He calls them the underground astronauts. For several weeks they descend into the dark, equipped with headlamps, and bring up, bone by bone, what will turn out to be one of the richest human fossil collections ever discovered. Over 1,550 bone fragments belonging to at least 15 distinct individuals: men, women, children, infants. A chamber full of the dead. What does it mean? That is where the debate begins. Lee Berger and his team published the hypothesis in 2023 that the bones of Homo naledi were intentionally placed in these chambers by members of their own species as a primitive form of burial. They also pointed out marks on the walls that could be intentional engravings and traces of hearths. If all of this is accurate, Homo naledi buried its dead, perhaps made art, and perhaps used fire. With a brain 1/3 the size of ours, the reaction from the scientific community was skeptical, and honestly, the skepticism is justified. Researchers like Chris Stringer of the Natural History Museum in London and Francesco Derrico have asked for more solid proof. The geological context of the bones is complex. Caves collapse, sediments shift, animals drag carcasses. Without an exhaustive taphonomic analysis, the study of what happens to bones after death, the interpretation of an intentional burial, remains fragile. This debate is unresolved, and that is not a weakness. This is what science looks like when it is working on a difficult question. But here is what is indisputable. The bones are there, in chambers that nothing other than intentional beings had any reason to reach. And there are no traces of predators, no claw marks, no signs of being washed in by water. Something or someone brought those bodies there. There is something that needs to be said out loud about the debate surrounding Homo naledi. It reveals our own biases more than it reveals anything about this species. We have a hard time accepting that a being with a small brain could have complex symbolic behavior because we have built our entire idea of human value on the size and complexity of the brain. Intelligence measured, quantified, ranked is at the very heart of how we think of ourselves as an exceptional species. Homo naledi poses an uncomfortable question. What if being exceptional wasn't tied to brain size the way we assumed? What if certain forms of symbolic behavior were possible with less grey matter than we thought? The answer to that question, whatever it may be, will change how we understand what makes us human. And that is perhaps why the debate is so fierce. In the absolute dark of the Rising Star Cave, 30 miles from where modern humans drive cars and check their phones, The bones of Homo naledi have rested for at least 236,000 years. No one yet knows truly why they are there. And in that uncertainty, in that silence of the rock, surrounding bones that pose a question we don't yet know how to answer, there is something profoundly human. Not because Homo naledi was human in the way we usually mean it, but because the question, what do we do with our dead, is perhaps older than we ever thought. And a little further north, at the exact same moment on the prehistoric timeline, another cave on another island holds the traces of a species no one had looked for because no one knew it could exist. Chapter 8. The Surprise of Callao. A species we didn't expect in the Philippines. In the Rising Star Cave, bones that no one yet knows how to interpret. And thousands of miles to the northeast, in another cave on another island, another story played out. The story of a researcher who thought he was holding something familiar and who was wrong from the very beginning. Here is an uncomfortable truth about science. It is often limited by its own categories. When an archaeologist finds a bone in the cave, and that bone looks like a modern human's, he classifies what he sees. Homo sapiens. There the box is checked. The work continues. This isn't negligence. It is the way research functions. We work with the categories we have, until the moment the data forces us to create new ones. In 2007, the Filipino archaeologist Armand Mijares is excavating Callao Cave in the northern part of the island of Luzon. He finds a metatarsal, a foot bone. He attributes it to Homo sapiens. The dating indicates roughly 67,000 years ago. It is the oldest proof of human presence in the Philippines. Remarkable, noted archived. We move on. In 2018 and 2019, new excavations in the same cave bring up more bones, teeth, finger bones, other foot bones, belonging to at least 3 individuals. And there, looking at the whole, not just a single isolated bone, but a collection, Mijares and his French colleague Florent Detroit see something that doesn't fit. The teeth are too small. The toe bones are curved in an archaic way, a shape found in Australopithecines, not in Homo sapiens. The combination of traits is impossible for a modern human, and it doesn't match Neanderthals, Denisovans, or Homo floresiensis either. In 2019, they officially describe a new species in the journal Nature, Homo luzonensis. Homo luzonensis is intriguing for several reasons beyond its mere existence. First, its date. They lived in the Philippines at least 50,000 to 67,000 years ago. That is exactly the period during which Homo sapiens was beginning to cross Southeast Asia. Once again, that temporal coincidence. Next, its morphology. A baffling mix of archaic traits, the curved phalanges recalling Australopithecines, primitive dental characteristics, and more modern traits, as if evolution, in the isolation of the island of Luzon, had assembled a being from pieces we would never have thought to see together in that era. Finally, its probable ancestor. Who was he or she? The most likely trail leads to Homo erectus, who might have reached Luzon perhaps 1 million years ago and evolved in isolation all that time. But the small size of the Callao bones also brings Homo floresiensis to mind. A possible evolutionary convergence between 2 different islands, 2 different populations, and 2 parallel histories of island shrinking and adaptation. Luzon and Flores separated by thousands of miles of ocean, independently producing small-statured human beings with archaic traits. As if island isolation had its own rules, its own tendencies, its own way of sculpting life, according to a logic that doesn't need to be coordinated in order to converge. There is something almost dizzying about this growing list. Homo erectus in Java, Homo heidelbergensis in Europe, the Neanderthals, the Denisovans, Homo floresiensis in Flores, Homo naledi in South Africa, Homo luzonensis in the Philippines. And beneath all that, a genetic fact that researchers have established in recent years, suggesting that this list is not yet complete. In the genomes of certain sub-Saharan African populations, particularly the Yoruba of Nigeria, the Mende of Sierra Leone, and the Biaka of Central Africa, there are DNA sequences that do not match Neanderthals, nor Denisovans, nor any known human species. Genetic ghosts of one or more lineages that existed in Africa that interbred with our African ancestors, and of which no identified fossil remains. Species that lived that disappeared, and whose names we do not even know. There is something melancholic in that idea. Entire beings, entire generations of individuals who lived, loved their children, cared for their wounded, perhaps did something with their dead, who left no visible trace in the fossil record, just a shadow in the DNA. A presence so faint it only has a name by default. Ghost. The story of Homo luzonensis also reminds us of something important about science itself. What we know is always less than what we do not know. Not because science fails, but because reality is richer than our tools for grasping it. A dozen years ago, the metatarsal from Callao Cave was classified as Homo sapiens. Today, it belongs to an entirely new species. Nothing changed in that bone. What changed was the accumulation of data around it and the willingness of researchers to revisit a classification that seemed certain. That is perhaps the central lesson of this entire story. The extinct human species have not all been found. Some are still waiting in caves no one has yet visited, on islands whose geological archives haven't yet been excavated, in genomes we haven't yet fully read. The story is not over. It is ongoing. But before they disappeared, all these species, in all these places something happened between them and us, something that neither fossils nor tools alone could have told us, something that only DNA could reveal. Chapter 9. The Great Mixing. When the species met, they didn't always fight. The islands of Southeast Asia. Small, archaic beings living their lives in limestone caves that no one else had visited. And meanwhile, on the continents and in the plains, something more complex than competition was playing out. When you imagine the encounter between Homo sapiens and the Neanderthals, what image comes to mind? A confrontation, perhaps. Two rival groups, two species competing for the same territory, the same prey. A kind of prehistoric war, silent, unrecorded, but no less brutal for it. That is the image that dominated for decades, and the genetic data complicated it irreversibly. What we know today is this. Homo sapiens and Neanderthals reproduced together multiple times in different eras, in different regions. The most recent genetic analyses suggest that the bulk of genetic exchange occurred between 50,000 and 60,000 years ago, meaning right around the time our ancestors were leaving Africa and entering the Near East, before even reaching Europe. Other episodes of hybridization may have happened later in Europe itself, during the period of coexistence. A study published in December 2024 in Nature refined this timeline, suggesting genetic exchanges occurred more recently than we thought, within the last 50,000 years. And in February 2026, a new analysis of Neanderthal X chromosomes revealed something else. The nature of these exchanges was asymmetrical. Neanderthal males and Homo sapiens females seem to have met and reproduced more often than the reverse. This is not speculation. It is what the chromosomal data shows. What did that mean concretely on the ground, that Homo sapiens women and Neanderthal men met in circumstances we cannot perfectly reconstruct, and from those encounters children were born? Children who lived, who grew up, who in turn had children, mixed families silent in the fossil record, present forever in the genomes. And then there is Denny. Do you remember her from the earlier chapter, the Denisovan teenager whose mother was Neanderthal? Let's bring her back here, because she is the most powerful symbol of everything we are trying to understand in this chapter. She was about 13 years old when she died. 90,000 years ago, in the Altai Mountains of Siberia, leaving only a fragment of a long bone the size of 2 thumbs, surviving in the cold rock of Denisova cave for 900 centuries. Her mother was Neanderthal, her father was Denisovan, but here is the part I saved for now. Her Neanderthal mother already carried traces of Denisovan DNA in her genome, and her Denisovan father carried traces of DNA from an even older Neanderthal lineage. These two species were not meeting for the first time. They had a history, generations of previous exchanges, encounters that had left traces in the bloodlines invisible to the individuals who carried them, but readable today in the double helix of a little girl who died 90,000 years ago. Denny was not an anomaly. She was the expression of a world much more blended, much more porous between species than we had ever imagined. There is a profound paradox in all of this, and it deserves to be named. These very species with which we mixed the Neanderthals, the Denisovans, have disappeared. If we had children together, what exactly do we call that? An extinction? An absorption? An incomplete fusion? The honest answer is a bit of all three. Neanderthals didn't suddenly go extinct one day in a clean, definitive way. Their population was already shrinking, and their groups were small, scattered, probably less cognitively flexible than the groups of Homo sapiens expanding around them. Over generations, hybrid individuals integrated into the more numerous, more connected Homo sapiens populations, which were better able to share resources over long distances. The purely Neanderthal populations dwindled, the last ones perhaps finding themselves in refuges like Gibraltar or the Carpathians, surviving a few more millennia before the thread finally snapped. The boundary between extinction and absorption is blurry, and that blurriness is perhaps more accurate than all the sharp, clean images we would like to have. What you carry in your body, if you are of non-African descent, is not just Neanderthal DNA in the abstract sense. These are concrete biological functions. Neanderthal variants influence your innate immune system. The way your body responds to certain pathogens in a matter of hours before adaptive immunity even kicks in. Variants influence your skin and your hair. Some are associated with faster blood clotting, useful in case of injury, less useful if you're at risk for cardiovascular disease. One variant even reportedly influences certain aspects of your circadian cycle, your tendency to be a morning person or a night owl. These legacies are not uniformly beneficial. Some Neanderthal variants increase the risk of certain pathologies. Evolution does not optimize for the big picture. It selects for the conditions of the moment, not for a future no one can foresee. But they are there, active functional Neanderthal.
And in Melanesian and Aboriginal Australian populations, the same goes for the Denisovans. Certain Denisovan variants influence the immune system, others the tolerance to certain dietary lipids, perhaps an advantage in coastal environments rich in marine fats. The Great Mixing was not just a reproductive anecdote, it was an exchange of biological solutions, adaptations that each species had developed over its own millennia, transmitted during encounters that may have only lasted a generation, but whose effects are still measured in living bodies today. A man and a woman in a forest or a plain 55,000 years ago. One is Homo sapiens, the other is Neanderthal. They do not speak the same language, perhaps not at all. They look at each other from a distance that isn't hostile, but isn't yet trusting. Then something happens. We will never know exactly what. Curiosity, violence, tenderness perhaps, a bit of all of that. Differently, depending on the encounters, the individuals, the circumstances. But a child is born, and that child has children, and those children have children. And you are here tonight in your bed with a little piece of that encounter in your genome. Silent, anonymous. 55,000 years old. But if our ancestors mixed with the other human species, why did those species disappear anyway? If children could be born, if mixed families could exist, what made the Neanderthals, the Denisovans, and all the others ultimately vanish? Chapter 10. The Great Question. Why did they all disappear when we arrived? Children born of two species, genes crossing the boundaries of life. And yet in the end, always in the end, one species remains standing, the same one, always the same one. How? There is one thing I must tell you right away. We do not know. Not entirely. Not with the certainty we would like to have when asking such a fundamental question. What we have are several serious hypotheses, each with evidence to support it, each with gaps that the other hypotheses try to fill. And one fact that resists all partial explanations. Every time Homo sapiens arrived in a region populated by another human species, that other species disappeared in the following millennia. Every time, without known exception. Java, Europe. The Philippines, Southeast Asia, South Africa. The coincidence is too repeated to be a coincidence. The first, most direct hypothesis is competition for resources. Homo sapiens and Neanderthals hunted the same prey, occupied similar shelters, lived in comparable environments. If groups of Homo sapiens were slightly more efficient, slightly better at transmitting techniques, building trade networks, sharing information about herd migrations, then over hundreds of generations, the Neanderthals would have gradually lost ground without ever enduring a decisive direct confrontation. No war, just a slow, repeated asymmetry that builds up. A study published in 2018 in Nature Communications modeled this dynamic and concluded that a difference in fertility or infant survival rates of just 1% between the two species would have been enough to eliminate the Neanderthals in a few thousand years, without any violent contact necessary. 1%. Not overwhelming superiority, a slight asymmetry maintained over time. The second hypothesis, which does not exclude the first, concerns disease. When modern human populations met isolated populations for the first time during the great European explorations of the 15th and 16th centuries, the devastating effects of the pathogens brought by one to the other were catastrophic. Populations that had never been exposed to certain viruses or bacteria died in droves without immune defense. Our ancestors, arriving from Africa with a longer and more diverse evolutionary history, perhaps carried pathogens to which the Neanderthal populations of Europe had never been exposed. This isn't hypothetical. It is the very principle of emerging diseases. And the Neanderthals, with their small populations and limited contact networks, would have had a reduced capacity to develop resistance quickly. Diseases kill silently. They don't leave marks on bones. We never see them in the fossil record. But their absence in the archives does not prove their absence in fact. The third hypothesis is perhaps the most troubling for our image of ourselves. Homo sapiens is among all primates and among all known hominins, the species with the greatest capacity to form coalitions between strangers. Tribes of Homo sapiens could cooperate with other tribes of Homo sapiens, share resources, lend individuals, ally against common threats even between groups that did not know each other. This capacity, which relies largely on symbolic language and shared representations, beliefs, stories, collective identity, is perhaps what most concretely distinguished Homo sapiens from the other human species. Not an abstractly superior intelligence, not necessarily more sophisticated tools, but the ability to get 200 people to agree on a common goal without each of them knowing the others personally. Neanderthals likely lived in groups of 20 to 30 individuals, rarely in sustained contact with other groups. Homo sapiens could coordinate hundreds of people at once. In a competition for finite resources, that asymmetry is no anecdote. And then there is the climate. The 50,000 years before our era were characterized by brutal climatic oscillations, rapid warming and cooling that transformed landscapes in a matter of centuries. Forests became steppes, steppes became tundras. The great prey of the plains disappeared to the north or the south. Neanderthals had survived many previous glacial cycles, but they did so starting from relatively large populations capable of absorbing local losses. By 40,000 BCE, Neanderthal populations were perhaps already weakened by generations of competition with Homo sapiens. Smaller, more fragmented, less capable of responding to a new climatic shock. A sudden freeze, shrinking resources, an already fragile population, and groups of Homo sapiens moving in to fill the vacated territories. None of these hypotheses alone is enough. Together, they form a picture that resembles reality. Not a clean, clear extinction, but a multilateral, regressive squeeze, at the end of which there are simply not enough Neanderthals left for a viable population to maintain itself. There is a question researchers don't often ask out loud, but which the data invites us to ask. Did we do it on purpose? The answer is almost certainly no. Not in the sense of a deliberate intention, an organized plan, a conscious decision to eliminate another species. The humans of that era had no concept of another species as an abstract category. They had neighbors, rivals, strangers. They acted according to their immediate interests, as all species do. But the consequences of their actions, their expansion, their efficiency, their ability to adapt and organize into large networks produced the result we know, not through malice, through efficiency. And this distinction between intentions and consequences is one we still haven't fully resolved in how we think about our own history. There is one last thing to understand before this night ends: what the extinct species left us. Not just in our genomes, but in our way of seeing the world, of caring for our loved ones, of asking ourselves what we do with our dead. Chapter 11. What they left us. The extinct species,
that still live inside you.
The question of the causes of extinction remains open, standing in the dark of prehistory. But before we set that question down for good and leave it with you, there is something else to understand.
Something that transforms the meaning of this entire story. The Neanderthals disappeared 40,000 years ago. The Denisovans probably 50,000 years ago, or maybe less. Homo floresiensis perhaps 50,000 years ago.
All the other species we have encountered tonight, extinct, buried silent for tens of millennia.
And yet, certain parts of what these beings biologically were continue to exist, not as fossils, not as archives, as living matter in bodies that breathe, that run, that care for their children, that fall asleep at night with a vague thought about the history of the world. This chapter is a list, but not a cold list. A list of gifts received without knowing. Start with the immune system. Several Neanderthal genes present in the genomes of non-African humans code for receptors of innate immunity, toll-like receptors, which recognize bacterial and viral pathogens. These variants were positively selected in modern human populations, meaning they conferred a real survival advantage in the European and Asian environments that Neanderthals had occupied for 300,000 years. In other words, Neanderthals had developed, over their millennia in Europe, immune defenses adapted to the pathogens of that continent. When our ancestors arrived in these environments, they didn't know they inherited some of these defenses through interbreeding. The individuals who carried these Neanderthal variants survived better. Their descendants were more numerous. This is no evolutionary anecdote. It is perhaps partly what allowed Homo sapiens to colonize Europe and Asia with such speed. Keratin. Neanderthal variants influence the production of keratin, the structural protein that makes up your nails, your hair, and the superficial layers of your skin. Some of these variants are associated with slightly thicker skin hair of a different texture, a possible adaptation to the cold and dry environments of Europe and Central Asia. You don't see it, you don't feel it. But if you look at your hands tonight, there is a non-negligible possibility that the way your skin is structured on a molecular level you cannot perceive is partly a Neanderthal response to a European winter 40,000 years ago. And then sleep. Several genetic studies have identified Neanderthal DNA variants that influence the circadian rhythm, the internal clock that regulates your sleep-wake cycle. These variants are associated with a more or less pronounced tendency to be a morning person or a night owl, to fall asleep earlier or later, to function better at the start of the day or the end of the evening. It is not possible to say with certainty what these variants meant for the Neanderthals themselves, but we can imagine that an internal clock calibrated for the long nights of European winters or the short nights of polar summers had its own adaptive logic. Tonight, if you have trouble falling asleep at the time you set for yourself, if you are naturally a night owl, if you wake up at dawn without being able to do otherwise, there is perhaps a tiny fraction of a Neanderthal in your clock. It is not a certainty. It is a possibility that the data makes serious. The EPAS1 gene of the Tibetans you already know, but there are other lesser-known Denisovan legacies. Denisovan variants in Melanesian populations influence the immune response to tropical parasites, particularly in coastal and island regions where humid environments favor specific pathogens. These variants, developed by Denisovans in environments they occupied for hundreds of millennia,
became survival tools for the populations that inherited them. The physical world in which the Denisovans lived, its pathogens, its parasites, its altitudes, its coasts, left an imprint in the bodies of the people who inhabit those same regions today. The territory shapes the bodies of those who inhabit it, and that shaping can cross hundreds of millennia, passing from one species to another in a fragment of DNA transmitted during a night no one remembers. There is something I want you to take away from this chapter. Disappearance is not the opposite of continuity. Homo neanderthalensis no longer exists as a species, but the biological functions they developed during 300,000 years of adaptation to Europe, those functions continue. They operate in modern human bodies every single moment. They don't know they come from elsewhere. They remember nothing. They simply function. The continuity of life is stranger and more beautiful than the idea of a direct, uninterrupted lineage. It passes through crossroads exchanges, hybridizations that seemed improbable and that happened anyway. It passes through little girls who leave behind only a pinky finger, and that pinky finger contains an entire history. Every human body living today is an archive of encounters. Some of these encounters we know about now, others we may never know. But they took place, and their effects are there in every breath, in every immune response, in every night of sleep that is a little too short or a little too long. There is a sentence Svante Pääbo said in an interview after receiving the Nobel Prize in 2022. It is simple, it doesn't try to be profound, but it is anyway. He said that what surprised him the most in his entire career was not finding Neanderthal DNA in modern humans. It was realizing just how functional those sequences were, not inert genetic fossils, active segments influencing real biological processes. As if they had never stopped belonging to someone. They never stopped. They just changed bodies. And now there is only one last thing to say, only one last question to ask in the dark of this night in your bed, after everything we have traversed together. Chapter 12. The night without the others, and what their absence tells us about ourselves. Those genes the extinct species left you active and silent at once in every cell of your body. And now come back to the surface. Leave the genes and the caves. Return to this night, to this planet, to this precise moment, where a single species of the genus Homo lies down, breathing softly in the dark. For the first time in at least 300,000 years, and perhaps much longer, it is only us. That sentence deserves to be spoken slowly. It is only us. Homo sapiens. 8 billion copies across continents, in cities of 10 million people, on orbiting satellites, in submarines beneath polar ice, in hospitals and universities, in villages without electricity, in refugee camps and in monasteries, on plateaus where the air is too thin for most of us to walk easily. A single species. There has never been this in the entire history of the genus Homo. Never. Not a single period in the history of the last 2 million years during which a single human species occupied the entire planet. It is an unprecedented situation, and we don't recognize it as such because we were born into it. Think about what it means to be a species without equivalent. For the entire duration of Homo sapiens' existence, from the first skulls of Jebel Irhoud in Morocco down to the current generations, there were others. Other bipedal beings, other brains, other hands that shaped stone or carried fire or laid their dead in caverns. Our ancestors evolved in a world where human alterity was a concrete reality. where crossing paths with someone of a closely related but distinct species was possible, perhaps not even rare in certain regions. This pressure, the presence of other non-sapiens humans, may have shaped aspects of our social psychology that we haven't yet fully understood. Our intense need to categorize strangers, our reflex to distinguish the in-group and the out-group, the alike and the different, the near and the far. Our ability to recognize humanity in a face that does not look exactly like ours, and sometimes our inability to do so. These traits perhaps do not come from nowhere. They were perhaps forged in a world where the question, "Is this being one of ours?" had a real biological answer, not just a cultural one. There is something unsettling in the list of species we have encountered, all of which have disappeared. Not because we are necessarily guilty of their disappearance in the moral sense of the term, but because the pattern is there, real, repeated, impossible to deny. Everywhere Homo sapiens arrived with sufficient numbers and efficiency, the other human species did not survive. Not once. And that same logic, Homo sapiens, expansive, efficient, organized in vast networks, consuming available resources, is visible in what we are doing today to other animal species, to ecosystems, to the climate of the entire planet. We haven't become something else, we just scaled up. This isn't an accusation, it is an observation. And honest observations are sometimes the most uncomfortable to hold. But there is another way to read this story. A way that doesn't deny the discomfort, but completes it. We are the species that discovered that other human species had existed, who developed the tools, paleontology, ancient genetics, paleogenomics, to find them, name them, understand them. Who extracted DNA from a fragment of a phalanx the size of a button to reveal the existence of an entire people? We are the only human species to have asked what happened to the others. That is perhaps the strangest thing we have ever done, and one of the most beautiful. Svante Pääbo dedicated his life to finding people missing for 50,000 years, using bone fragments that most people threw away without a second thought. Lee Berger crawled through 7-inch tunnels to find beings buried for 236,000 years. Entire teams of researchers around the world work with patience and rigor to reconstruct lives of which there remains perhaps only a tooth, a finger bone, a shadow in a genome. It is a form of memory, a form of respect. The longest vigil in human history, sitting around the fire of data, recalling the names of those who are no longer here. There is a tradition in many cultures across the globe. Before electricity, before radio, before screens, families and communities gathered in the evening around a fire or a lamp to tell stories. The medieval storytellers, the grandmothers, keeping alive the tales of the old country. The griots of West Africa, carrying the memory of dozens of generations in their voice alone. What you are doing right now. Listening to a voice in the dark telling you something true before you fall asleep. It is one of the oldest things humans do together, probably since before there were words for it. Perhaps since the fires of Shanidar and Atapuerca and Liang Bua. Perhaps since long before that. I took you tonight from the banks of the Solo River to the heights of the Himalayas. From the pinky finger of a Siberian girl to the curved toe bones of a Philippine creature no one expected. From bones in a stone pit in Spain to the genes active in your cells tonight. This journey has no neat conclusion. It doesn't have one because the story isn't over. New human species will probably be discovered in caves not yet excavated, in genomes not yet read. New evidence will change some of the things I told you tonight.
That is the nature of science, and it is what makes it alive. In 10 years, in 20 years, in 50 years, the picture we have of our own history will be even richer, even more complex, even less linear than what we can imagine today. But what we already know is enough to change something. Now let all of this settle gently. The species you met tonight, they didn't disappear cleanly all at once, in order. They slipped away, slowly, silently, without anyone noticing while they were alive. Homo erectus at Ngandong, on the banks of the Solo, perhaps a few dozen individuals, then a few, then one, then none. The Neanderthals in their last refuge in southern Europe, Gibraltar perhaps, the Carpathians. Groups getting smaller and smaller, less and less connected to each other. The Denisovans somewhere in Asia, in a geography we cannot yet map, until the moment their thread too snapped. All those fires going out one by one, without a sound. And then silence. But not quite silence. Because in your body tonight, in that fragment of Neanderthal genome that perhaps influences your sleep, in that immune response inherited from a being dead for 40,000 years, and in that Denisovan gene helping someone, somewhere, to breathe on a plateau at 15,000 feet. There is still something living that comes from them. They are not entirely gone, they are just very small now. Dissolved into something larger, carried by billions of bodies that don't know they are carrying them. You might consider subscribing to this documentary channel if you want to continue this kind of evening vigil. A new story to listen to in the dark when the night is long and sleep is delayed. And if you want to leave a comment to say where you are listening from, New York, Texas, London, Sydney, Toronto, or any other corner of the English-speaking world, I would be genuinely touched to read it. But for now, you have nothing to do, nowhere to go. Just this bed, this night, this breath. Let the list fade away softly. Homo erectus gone. Homo heidelbergensis gone. The Neanderthals gone. The Denisovans gone. Homo floresiensis gone. Homo naledi gone. Homo luzonensis. The nameless African ghosts gone. There is only you in that bed tonight. Eyes closing slowly, breathing, deepening. Something very ancient continuing to beat softly beneath everything else. You are the last species, the last thread of a bush that shrank for millions of years until it kept only one. It is not a glory, it is not a curse, it is simply what is. And tonight, in the dark, at this hour, when words become rarer and images softer, you can let this thought rest without needing to resolve it. They were here, you are here, and something between them and you never entirely ceased. Good night.